Hi, everybody. Today I'm going to talk about Pivotal Cloud Foundry's use of Cassandra and the product that we're building for deploying Cassandra clusters on-premise behind the firewall in a kind of automated fashion. It's a partnership between Pivotal and DataStax that we're going to be releasing in the next couple of weeks. So first, my name is Tammer Saleh. I'm the Director of Product for Pivotal Cloud Foundry. I'm actually in London. Flew in for this event, which is marvelous, incredible. I also was an engineer for Pivotal for a while, spent some time pairing on the runtime team. In the past, I've ran consulting companies as Director of Engineering for Engine Yard and various other things. Today we're going to talk about a bunch of things. It's a lot of content to get through, so I'm going to try and move through it quickly. I'm going to give you a quick overview of Pivotal Cloud Foundry, what it is and how it works. I'm going to talk about the Services API, and I'm also going to talk about why we chose Cassandra as the data store to focus upon, how we built Cassandra as a service available at a platform, and how we automated Cassandra operations. So first, let's give a quick overview of Pivotal CF. Pivotal CF is a platform as a service. Who here is familiar with Cloud Foundry in general? Raise your hands. Maybe Heroku or any other platform as a service? Yeah. So Pivotal CF is very similar to, it is an on-premise deployment of Cloud Foundry. It's very similar to Heroku and how you use it. And the idea is that we can give developers agility by removing all of the friction from getting their app from a developed application into production, right? And a phrase that we like to use in Pivotal is CF push is golden, and that really what we're saying is a single command to push your app into production is the user experience goal that we're focused upon. Now, frankly, nowadays, anybody can produce a stateless platform. That's kind of table stakes for the cloud world at this point. It's really about services, how you bind services, and how you add state to that. So here I've shown all the commands for producing or pushing an application to production and binding a stateful service to it, and then immediately seeing that up online. Now, with Pivotal CF, there's also not just the command line interface, but there's also an operator-focused dashboard and the application developer-focused dashboard. So Pivotal CF is it's infrastructure agnostic. So Cloud Foundry runs on vSphere, AWS, and OpenStack, and Pivotal CF basically comes in as an appliance that you deploy. It uses a technology we developed called BOSH on the back end. I'm going to talk a little bit more about that. And again, it shows a web-based dashboard to the operator so they can easily install other things like Cassandra alongside it. When the operator installs the runtime tile, which is the heart of Cloud Foundry, Ops Manager deploys this complex system, which basically involves a routing layer, a layer for managing the applications, the application lifecycle, single sign-on, things like that, a health manager to make sure everything keeps running. And then alongside that, they can install other tiles like Cassandra, and those are deployed as services that talk to the runtime and enable the integrations. And then finally, there's the application developer console, which is deployed alongside it as well. So real quick, let's talk about the Services API and how that works. So let's look again at kind of a simplified version of the internals of Cloud Foundry. You can see here we've got, again, the operations manager. We've got Bosch behind it on top of the infrastructure. And we've already deployed the Cloud Foundry runtime. We've got the router, and then we've got some application instances and the cloud controller, which is the API endpoint that manages the whole thing. Now, the operator has now deployed a service next to it. The service is it's all about the service broker, which is a very small API endpoint that communicates with the cloud controller, and the concept of service instances that the application developers requested. So let's kind of go through the workflow here. Application developer, and I like the command line because I'm a Unix geek, so most of the stuff I talk about is going to be on the command line, but of course this all works through the dashboard as well. But the application developer says, okay, CF Marketplace, tell me what you have for data services. The cloud controller then reaches out to the service broker. It says, what do you have? The service broker says, well, I've got Cassandra, right? And then the cloud controller says, here's what we have available. One of the services is Cassandra. And this is a view of the dashboard, but in the command line, you just get that listing right there. So the application developer says, sweet, I like Cassandra. I want to get that, right? So they create that service. When they run CF create service, the cloud controller talks back to the services API again on the broker and says, okay, give me an instance of this. And you can see the little blue instance that now popped up. At that point, the service broker has actually made a database for the application developer, right? Now, it's just sitting out there. There's nothing talking to it. You can bind it to an application. So the application developer says, bind the service to my app. The blue dot on the left is the application, blue dot on the right is the service instance. So when he says bind it, it provisions a binding. The binding gets returned as basically an environment variable that is exposed to the application instance, right? From that point forward, all communication goes directly from the application instance to the service instance directly. We don't get in the way, right? Now the reason for that two-phase approach where you provision the service and then you bind it to the application is so that you can bind that service to multiple applications, right? Depending on how you want to do your microservices architecture, you might want a shared database on the back end. But the point of this is the services API is incredibly simple and incredibly easy to implement. This is literally all of the RESTful API calls for this API, and I'll point out that these are all the verbs we support as well. There are only 5 permutations. So you can write a service broker trivially in something like Sinatra via Ruby or via Java. It's very easy. The complexity of doing a service is not in the API, it's in the implementation behind it, which we'll talk a lot about. So real quick, I want to talk about what services we're focusing on for Pivotal and kind of get into why Cassandra is the one that we're taking to production first. We have Redis, which is a KV store. I'm sure everybody's heard of these databases, so I'm going to kind of move through it quickly. Redis is one of my favorites. It's, somebody referred to it as the AK-47 of data stores. It's very focused in what it can do. It's rock solid, but it doesn't scale very well in terms of number of nodes. I think you can do master-slave at the moment, clustering coming out later, nothing like Cassandra. Neo4j for graph database, Elasticsearch for full-text searching, MongoDB for a fast and easy NoSQL store, Memcache for caching, MariaDB for MySQL. We have our own services like our Hadoop distribution, PhD, React.cs for a blob store, S3 compatible, and then of course Cassandra, highly distributed, write-heavy KV/column store. So these are the focuses of what we're going to be releasing with Pivotal CF. Some of these are already released, some of these are in progress right now with the London team. So Cassandra is our first production-grade service, and some people have asked, why are we focusing on Cassandra? I think it's pretty clear, though. This is an independent study that was done by the University of Toronto in 2012. Has anybody seen this study? Raise your hands. This is great because it really outlines the fact, or underlines the fact that Cassandra is the cloud store of the future. It scales linearly. They did a review of all of the NoSQL open source stores that they could find, and Cassandra was the only one that performed this well. And of course, Netflix has shown that they were able to get up to, I think it's 1 million writes per second with Cassandra, and again, linear scaling. It's very rare in computer science to see a system that actually scales this linearly. It's really impressive. So we believe, Cassandra is truly cloud scale. Cassandra supports multi-data center deployments, And nowadays, given the cloud, a multi-data center deployment is commonplace. I remember when I used to be a Unix administrator for CitySearch, we had 2 data centers, one in Los Angeles, one in Chicago, and that was cutting edge for us to have that kind of distributed system. But even then, it was just a master-slave failover. Nowadays, with Amazon and with various cloud technologies, it's very easy and commonplace to be deploying your application across multiple data centers. Cassandra is the best data store to support that. So let's talk about how we built Cassandra in terms of the architecture when it's a service that integrates with the platform. So again, I said the services API is actually quite simple. You've got kind of these 4 main terms. You got the service itself, which is kind of a meta term. It means what exactly is the technology that you're deploying. For, in this situation, of course, it's Cassandra. You can choose the various plans in that service, which is nice. It gives the application developer a little bit of tweaking. I want a small, medium, or large Cassandra, right? And then you provision the Cassandra instance, and then you bind it. And again, the binding is just a user account and some credentials that gets passed back to the application. The real trick is, what is an instance? Whenever you're building out a new service, you have to think long and hard about exactly what the user gets when they say, I want an instance of service X, right? So initially, the easiest way of getting a service out into the world is to do a what we call multi-tenant installation. So we have this available right now in beta form for the Cassandra product. And what this means is it's one Cassandra cluster that is divvied up amongst users, right? When I ask for an instance of Cassandra, what I actually get is a single key space and a user that has access to that key space. So this works actually fairly well with Cassandra in terms of scaling. As we've already seen, Cassandra can scale out linearly. And it's good for development and testing and staging environments. Unfortunately, there's some limitations of Cassandra, which means that it's not good for heavy production use, and it's not good for strictly untrusted environments. So let's talk about a couple of those limitations. Key space visibility, this is the biggest one. So basically, there's no way in Cassandra to say that user A cannot see the names of all the key spaces in the system. All right? Now, that's not a huge security concern for us because in CloudFoundry, the key space names are actually just randomized GUIDs. A user can see that there's 20 key spaces or 200 key spaces, but that's not really a big deal. A bigger problem with key space visibility is that in Cassandra, there's also not a way to say that user A cannot see the names of tables inside the key space. Now, the names of the tables inside the key spaces are determined by the other users. So there is some information leakage there that makes this only appropriate, for, again, for semi-trusted environments. Now, Pivotal CF is designed to be deployed behind the firewall inside private institutions, so it's still useful, again, for staging and development environments. There's also the noisy neighbor problem. In Cassandra, there's no way to limit the amount of, for example, the amount of CPU that's used by queries against a single key space, the amount of memory that's used for queries against a single key space, or the amount of disk space that's used by a key space. We actually did some research to see if we could just make use of the underlying Unix system quotas to deal with the disk quota at least, the key space size. That would kind of work. The problem is that the way Cassandra dumps the, I think it's SS tables, means that it'd be easy to kind of overrun that quota and then lose data. And that's absolutely unacceptable in our situation. So noisy neighbors is a problem with a multi-tenant Cassandra. And again, quotas as well. Noisy neighbors for CPU, quotas for things like disk and memory. So we have the multi-tenant Cassandra, which is good for application development and staging, but when we really want to push it out to production, we need to think bigger, right? So for production level, when a user requests a Cassandra instance, what they're actually going to get is a set of dedicated VMs that are set up as a Cassandra cluster. In the initial version, we're just going to hard code that number, maybe 3. and probably one number per plan. So a user could say, I want the small plan, which is 3. I want the medium plan, which is, say, 10. I want the large plan, which is whatever the operator wants to make it. Now, this is truly production grade. It's dedicated VMs as a cluster. There's no noisy neighbors whatsoever. There's no issues with quotas because the operator can set the size of the disks on these VMs. The only issue with it is it is quite expensive. The operator is clearly going to want to limit who can provision a production-level Cassandra cluster. There's also a middle ground, and by the way, this is what we recently reincepted about a week ago. So we had a big kickoff meeting where we defined the architecture, defined the stories. Pivotal's an agile organization, and we're actively building this version out for the production-level Cassandra. There's another architecture that we've been looking at closely, and it's something that we're considering. It's not quite clear if this is something that our customers are demanding yet, but it is, it's a possible architecture, which is basically a mix between the two. So it's a shared set of VMs, but when a user asks for a Cassandra instance, what they get is a set of Cassandra processes spread out across those VMs, configured as a cluster, wrapped inside containers. We use Warden for a containerization technology. You can also use Docker. And the key is that these would be shared in the VMs. So a set of VMs might be running, say 3 VMs might be running 20 Cassandra clusters, right? Now, because of Linux containerization technology that's rather, well, it's not new. It's actually been around for a long time, but it's constantly improving in what you can constrain with containers. It is possible to basically remove the noisy neighbor problem entirely. You can constrain, of course, how much disk space is being used, how much memory is being used, how much CPU. You can even constrain the networking aspects so the clusters can only talk to each other. You can do all kinds of things there. The nice thing about this is that a user would get access to the entire key space, or all of the key spaces. With a multi-tenant solution, a user just gets the one key space. Usually for Cassandra, that's the right way to go. Cassandra, usually you have a key space per application, but we have seen use cases where people want to be able to provision key spaces on the fly in order to segregate data. So that's the architecture of what we're building. Now let's talk about some of the issues with automating Cassandra. Let's see. Cassandra automation is, managing a Cassandra database is actually fairly complex, repairs and timings and such. We have a tool called BOSH, which makes all of this much easier. BOSH is our tool for deploying everything Cloud Foundry. I actually used to run product for BOSH, so I was running the BOSH team. I can say this because of that. BOSH is incredibly powerful. It's also incredibly painful to use. I like to make the analogy, BOSH is like this huge sword that you get to wield, but you have to hold it upside down. So you can get a lot done with it, but you're going to cut yourself in the process. That's why we built Ops Manager around BOSH to make the interface easier. So BOSH is a tool that is it's in the same space as Puppet or Chef or Salt or Ansible, but it takes things, it does things in a different way. It's predictable, it's repeatable, it's infrastructure agnostic, and it's built for large-scale deployments. BOSH takes care of the entire life cycle of a deployment. It takes care of provisioning the VMs, talking to the infrastructure to get that done. It takes care of configuring what's on the VMs. It takes care of juggling the persistent store for the VMs as well, all the networking, everything. BOSH is also very, like I said, predictable and repeatable because BOSH compiles everything from scratch. It does it once and uploads it to a blob store, and it uses the same set of blobs to lay down every VM that it deploys. That's also why BOSH is built for large-scale deployments. In addition, BOSH has features like canaries, rolling deployments. So when you want to update a BOSH deployment, say you make some changes to how your deployment works, and you run the BOSH update, it'll actually first deploy a canary, make sure that that's working fine. Then it will deploy all of the VMs, maybe in hundreds of VMs, in a rolling manner, maybe 10 at a time. You can configure that. BOSH also ensures that all the processes are running correctly on the VMs, the ones that you've told it to watch. And it makes sure that the VMs stay healthy. And that's a feature that we added to BOSH because of AWS, which is the BOSH Resurrector. Kind of a side story here is that we used to run our public Cloud Foundry installation on a vSphere installation, a vSphere data center that was absolutely production grade. EMC data storage, I think EMC servers as well. I think there were like guards with machine guns outside this building, right? Because of that, we didn't really have to worry about HA because VMs never went away, right? And then when I came onto Pivotal, my first task was to take this production platform, this public cloud, and move it over to AWS, which I like to refer to as the quantum flux of the cloud world. AWS is absolutely the worst API and the least reliable of any of the infrastructures that you could possibly work with. So because of that, we had to build more HA and more reliability into BOSH, and also we built this feature called the BOSH Resurrector. It's a very simple feature. Basically, on each one of the VMs that's deployed by BOSH, BOSH has an agent that's constantly heartbeating back into the BOSH director. Now, if at any point one of those agents, just the agent stops sending heartbeats, could be a network partition, could be anything. The agent could be down for some reason. BOSH doesn't really care. At that point, BOSH just sends a stoneth signal to the infrastructure and just wipes the entire VM off the network. Now again, BOSH is aware of the of the persistent store attached to the VM, so nothing's lost. It just recreates that VM and then attaches the persistent store again. Now the agent's heartbeating and everything just works fine. And this is proven to be one of the more important features of BOSH, especially when you're deploying it to something like AWS. Now, another interesting thing about Cassandra, who here knows about the issues with Cassandra and NTPD? Raise your hands. Not many people. Yeah, I see a few of you laughing because you probably had to configure this yourself in the past. There's a difference between precision and accuracy, which I think most of you probably understand. The interesting thing about Cassandra is that it's more important for the clocks on the various Cassandra VMs to be precise than accurate. I don't care if my Cassandra nodes think that it's 1912, as long as they all think that it's 1912, right? So the way that you get that done is in NTPD, which is the service that ensures that your VMs have the right time set on them. You can tell it to, I think they call it homing to peers. You can tell it to home to peers in a tiered fashion. So this is a very unusual configuration for VMs in a network, but basically you say, all of these nodes, I want them all to home to each other, right? You make a little mesh of NTP nodes. And that means that they're all going to, first and foremost, have the same time. Now, this entire little network can drift in terms of time. So eventually they can all be an hour off, but they're all going to be exactly that same hour off. So then, in order to add accuracy to it, we also tell them as a secondary source that they should all use another node in the same network as the secondary. So first and foremost, make sure that we're all on the same page. And second, let's all kind of look over here and see what the upstream says, right? Now, we already deploy a node for the service broker, so we just co-locate that NTPD server on the service broker. Now, in order to make sure that that's accurate with respect to the internet, that one service broker then homes up to whatever NTPD server you set in the Ops Manager configuration up in the internet. So there's actually a really great blog post, which is linked to down here, that describes not just this configuration, but kind of all of the sets of intermediate configurations that this person went through to figure out the best way of setting up time on a Cassandra cluster. Another aspect of maintaining and managing a Cassandra cluster is the repair life cycle. I'm sure everybody here has dealt with running repairs on a Cassandra cluster and all the times you might have to do that by hand. Now the challenge with Pivotal Cloud Foundry is that we're taking over the operations aspect of Cassandra on behalf of the operator, right? So we can't send any telemetry back to headquarters for us because it's all deployed behind a firewall, and most of the point of this is that companies don't want that stuff being sent out. So we can't send in our engineers when we notice that there's something wrong with one of the VMs, when a repair needs to be run or something like that. We have to build a system that will work like clockwork and keep the whole thing running on its own. So there's a set of times when we run repairs. The first one is when we're decommissioning a node and we know that that VM is going away permanently. Now, we don't run repairs when we know the node is coming right back. So if Bosch is doing a deployment and it has to recreate the VM for some reason, or if the resurrector ran and had to recreate the VM, we don't run a repair then, because in those situations you could actually end up running a repair across the entire cluster and really degrading performance. We also allow the operator to configure a time threshold when if the node has been down for longer than this period of time, then we run a repair when the node comes back. So if there was some downtime in the node for, say, 20 minutes, and the operator said 15 is their threshold, when the node comes back, we will run a repair on that node. The reason we have to make this configurable is because it actually has everything to do with the amount of data that's being written to the nodes per minute, right? And that's something that we can't know ahead of time, so we have to allow the operator to change that. We also run a repair on each node once a week within the GC grace period, and that has to do with tombstones and making sure that tombstones don't get destroyed, because then we see old data coming back, right? So the whole point of this is, like I said, nowadays it's almost with technologies like Docker, with all the new routing technologies that are coming out, it's not that difficult to produce kind of a toy platform. The real key is in producing something that manages itself, maintains itself, and that has highly available, stateful data services behind it. And we believe that those are the key differentiator for Pivotal CF. Our customers believe that as well. Our customers are really excited by the Cassandra product that we're building with the DataStax partnership. and it's one of the most important projects that we're working on right now. So anyways, I wanted to wrap that up quick. Thank you very much for your time. If this interests you, and if you're interested in living in London, we are hiring on the Cloud Foundry team over there.